June 6, 1944. D-Day, the largest amphibian invasion in human history. 156,000 Allied soldiers stormed the beaches of Normandy. 5,000 ships. 11,000 aircraft. The world holds its breath. And it works. The Allies break through Hitler's Atlantic Wall. Victory seems inevitable. But then, something goes terribly wrong. June 12, 1944. 6 days later. The Allied advance has completely stopped. Not because of German panzer divisions. Not because of the Luftwaffe. Not because of Hitler's secret weapons. American tanks are being destroyed at a rate of 15 per day by ancient French hedgerows. Bushes. Farmers' fences built centuries ago are now slaughtering American tank crews faster than any German weapon. By June 25th, over 200 Sherman tanks have been reduced to burning coffins. Generals are panicking. Intelligence is scrambling. Engineers have tried everything. Nothing works. And somewhere in that chaos, a mechanic from New Jersey named Curtis Cullin is watching his friends die. He has no engineering degree, no special training, no authority to solve anything. But he has an idea so crazy, so simple, so forbidden by conventional military thinking that his commanding officer will call him insane. 48 hours later, that same officer will be begging him to build more. General Eisenhower himself will order 5,000 copies manufactured. And military historians will later say that this one invention shortened the war by weeks. This is the story of how a nobody with a welding torch changed the course of World War II. The problem started with a catastrophic failure of intelligence. Allied planners had spent years preparing for D-Day. They had studied tide charts, beach gradients, German fortifications troop movements. They had built dummy armies to fool Hitler. They had cracked German codes. They had planned for almost everything. Except the hedgerows. Norman bocage. That's what the French called them. Walls of earth and stone and roots that farmers had built over 1,000 years to mark property lines and protect crops from coastal winds. Some dated back to Roman times. They covered the Normandy countryside like a maze dividing the entire landscape into thousands of small enclosed fields. Each field was a box. Each hedgerow was a wall. And there were thousands of them between the beaches and Paris. Allied planners had seen aerial photographs. They had noted the hedgerows on their maps, but they had assumed these were just bushes, just vegetation. Tanks would push through them like everything else. They were wrong. These hedgerows stood 15 feet tall. Some were equally thick. The roots went down 10 feet into the earth, tangled together into networks that had been growing for centuries. They weren't bushes, they were fortresses, and the Germans figured this out immediately. The killing started on June 7th. A Sherman tank approached a hedgerow trying to push through. The tank tilted upward as it climbed. Its belly armor became exposed. A German soldier on the other side fired a Panzerfaust. One shot. The tank exploded. 4 Americans died instantly. The 5th lived for 3 hours burning. This scene repeated itself dozens of times every day. The mechanics were brutal and simple. Sherman tanks had thick frontal armor that could withstand most German weapons. Their side armor was thinner but still protective. But their belly armor was just thin steel plate designed to stop mine fragments, nothing more. When a tank tilted to climb a hedgerow, this vulnerable belly became a perfect target. German defenders didn't need heavy weapons. They didn't need training. They just needed patience. Wait behind a hedgerow. Let the Americans come. Watch the tank tilt up. Fire into the exposed underside. Move to the next hedgerow. Repeat. The American tankers knew they were dying. They could see the math. Every hedgerow was a coin flip. Cross enough hedgerows, your number comes up. But what choice did they have? The orders said advance. The only way forward was over these walls. So they climbed and they died, and the survivors climbed the next one waiting for their turn. By mid-June, the situation was desperate. General Bradley had expected to be 30 miles inland by now. Instead, his forces were gaining only a few hundred yards per day. The breakout from Normandy, the entire strategic plan for liberating France, was failing. Not because of German strength, because of French landscaping. Engineers tried everything. Explosive charges bounced off the compacted earth. Bulldozer blades got tangled in roots. Artillery just churned the soil into mud. Someone suggested flamethrowers to burn through the vegetation, but that just created smoke that blinded everyone, and the roots remained solid. Nothing worked. Generals demanded solutions. Engineers made promises they couldn't keep. Meanwhile, American boys kept dying. 15 tanks a day, 60 men a day, 400 dead per week. Curtis Cullin wasn't supposed to be thinking about any of this. He was a cavalry reconnaissance mechanic. His job was keeping vehicles running, fixing engines, patching holes, making do with whatever parts were available. He'd been a mechanic in New Jersey before the war, working at a small garage fixing cars and trucks. Nothing glamorous, nothing special. Just a guy who understood machines. But Cullin had a habit that annoyed his crewmates. He couldn't stop solving problems. When something was broken, he couldn't walk away from it. When something didn't work, his brain wouldn't let it go. He'd lie awake at night turning the problem over and over, examining it from every angle until he found a solution. His fellow soldiers thought it was obsessive. Maybe it was. But it was also the reason he was good at his job. Cullin watched the Hedgerow disaster from the maintenance areas where burned tanks were brought for salvage. He saw what was left of the crews. He heard the survivors screaming in the medical tents. He watched mechanics strip parts from tanks that still smelled like death. And his brain wouldn't stop working on it. The problem wasn't the hedgerows themselves. The problem was the approach. Everyone was trying to go over. Every solution assumed tanks had to climb these walls. But climbing meant tilting. Tilting meant exposing the belly. Exposing the belly meant death. What if you didn't climb? What if you went through? Cullin mentioned the idea to his crewmates. They laughed. These hedgerows had stood for centuries. Stone and earth and roots packed so tight that explosives couldn't break them. And Cullin thought he could just drive through. With what he didn't have an answer yet. But the question wouldn't leave him alone. He started carrying a notebook sketching ideas during every spare moment. His crewmates noticed. "Cullin's at it again," they said. "Going to win the war with his little drawings." They didn't mean it cruelly. They liked Cullin. But they'd seen smart people fail at this problem. Generals and engineers with resources and authority had tried and failed. What made a mechanic from Jersey think he could do better? The answer came to Cullin while he was walking past the beaches where D-Day had happened. The sand was still littered with German obstacles, Czech hedgehogs, massive steel structures shaped like giant jacks, 3 iron beams welded together designed to rip open landing craft. The Germans had planted thousands of them. Most had been bypassed or destroyed during the initial assault. Now they were just scrap metal waiting to be cleared. Cullin stopped and stared at one. Steel beams, sharp angles, hardened metal designed to tear through things. His brain made a connection that nobody else had made. What if you welded those steel beams to the front of a tank, like tusks, like blades? The tank wouldn't try to climb the hedgerow. It would ram straight into the base, and the steel prongs would dig in, cutting through earth and roots. The tank stays level. The belly stays protected. The Germans can't shoot what they can't see. Cullin knew his idea sounded insane. He also knew it might work. The physics were solid. 30 tons of tank moving at speed focused through steel prongs into a concentrated point of impact. Something had to give. But knowing something might work and convincing the army to try it were completely different problems. Cullin was a sergeant. He had no authority to modify equipment. He had no engineering credentials to back up his theory. If he was wrong, he could get good men killed and himself court-martialed. He decided to try anyway. Captain Samuel Morrison was not having a good week. His unit had lost 3 tanks to hedgerow ambushes in the past 4 days. Replacements weren't coming fast enough. Morale was crumbling. And now one of his mechanics was standing in front of him proposing something that sounded like a suicide mission. Morrison listened to Cullin's proposal with growing disbelief. Weld scrap metal to a damaged tank. Drive it full speed into a stone wall. Hope it works. You understand this is insane, Sergeant. Yes, sir. The current plan is also insane. We're just more used to it. Morrison wanted to dismiss this immediately. But Cullin wasn't finished. He explained the physics, the angles, why frontal assault was actually safer than climbing, why the prongs would cut instead of bounce, why the tank would stay level instead of tilting. It made sense. God help him, it actually made sense. How long to build it? Morrison asked. 48 hours. Welding equipment and permission to scavenge from the beaches. I'll have a prototype ready. Morrison weighed the risks. If this failed spectacularly, he'd be explaining himself to very angry generals. If it worked, he'd be a hero. And either way, men were dying right now under the current approach. Something had to change. You've got 48 hours. Don't make me regret this. Cullin didn't sleep for the next 2 days. He commandeered a work crew, requisitioned torches and welding equipment, and headed to the beaches. They worked through darkness, cutting Czech hedgehogs apart, shaping the steel beams, sharpening the tips. Cullin calculated angles obsessively. Too high and the tank would still tilt. Too low and the prongs would just plow dirt. The angle had to be exactly right. 15 degrees downward. That would give optimal cutting action while keeping the tank level. By dawn of the second day, 4 steel prongs were welded to the front of a damaged but functional Sherman. Each prong was 4 feet long, thick as a man's leg, hard as railroad steel. The tank looked ridiculous, like something from a nightmare. Soldiers gathered to stare. Someone called it a rhinoceros. The name stuck. The first test happened that morning. A thick hedgerow 12 feet high, centuries old. The kind that had killed dozens of tanks. The rhinoceros faced it from 50 yards away. Cullin stood with the observers, his heart pounding so hard he could feel it in his throat. Everything he'd calculated. Everything he'd built. It all came down to the next 60 seconds. If the prongs snapped on impact, his idea was finished. If the tank got stuck, he'd be a joke. If it worked... The Sherman's engine roared. The tank accelerated, 30 tons of steel racing toward an immovable wall. The impact was thunderous. Earth exploded. Roots snapped like gunshots. For one terrible moment, the tank seemed to stop buried in the mass. Then it kept moving. The prongs were cutting, ripping, working. The tank burst through the other side. Clean breach, belly never exposed. The soldiers erupted. Cullen's legs went weak. It worked. His crazy, impossible, forbidden idea actually worked. But this was just a test. Captain Morrison was already thinking ahead. There's a German strongpoint 2 miles from here. They've been holding us up for 3 days. Every approach goes through hedgerows. Every attempt to cross has failed. He looked at Cullin. Tomorrow you prove this works for real. Under fire. Against the enemy. Cullin felt the fear settle into his stomach. One successful test didn't mean it would work in combat. Real battle was chaos. Things broke. Plans failed. People died. And now he was going to ride into that chaos on a tank covered in scrap metal, betting his life and 4 other men's lives on calculations he'd done in a notebook by lantern light. But he thought about the burned tanks. The screaming survivors. The crews who never got out. If his invention worked in combat, it would save hundreds of lives, maybe thousands. If it failed, at least he'd have tried. I'll be ready, sir. That night, Cullin checked every weld, every prong, every bolt. His hands were shaking. Tomorrow would tell whether he was a genius or a fool, whether his mad idea would save the invasion or get good men killed. What happened next shocked everyone. In Part 2, the rhinoceros faces real German guns. Cullin discovers whether his invention can survive actual combat. And the German defenders learn that their impenetrable hedgerow fortress has suddenly become worthless. The rules of warfare are about to change. Previously on this story, a mechanic from New Jersey named Curtis Cullin watched American tanks burn at the rate of 15 per day. Ancient hedgerows were turning Normandy into a graveyard. So Cullin did something insane. He welded scrap metal to a Sherman tank and created a weapon that could smash through barriers that had stopped everything else. The first test worked. The prototype proved his theory. But one successful test in a controlled environment means nothing if it can't survive real combat. Captain Morrison gave Cullin the ultimate challenge: a German strongpoint 2 miles away. 3 days of failed attacks. Every approach blocked by hedgerows. Every attempt ending in burning tanks and dead Americans. Tomorrow morning, the rhinoceros would face its first real battle. And if it failed, Cullin wouldn't just lose his invention. He'd lose his life and the lives of 4 men who trusted him. The stakes had never been higher. But what Cullin didn't know was that combat was only the first obstacle. Because even if his invention worked perfectly, even if it proved itself beyond any doubt, he would still have to face something far more dangerous than German guns. The United States Army Bureaucracy, June 25, 1944. Dawn. The air was cold and wet. Cullin climbed into the rhinoceros, taking position in the commander's cupola. His hands were steady, but his stomach churned. 4 other men were trusting their lives to his calculations. Corporal Jake Mitchell on the driver's seat, Sergeant Tom Harrison on the gun, Private Danny Chen loading ammunition, Private Eddie Kowalski on the hull machine gun. None of them had to be here. They'd all volunteered. "You really think this thing works?" Mitchell asked over the intercom. "It worked yesterday," Cullin replied. "Yesterday wasn't shooting at us." Cullin had no answer for that. The column moved out at 0600, rhinoceros in the lead, 2 standard Shermans behind, infantry following on foot. The German strongpoint was fortified behind 3 successive hedgerows. Intelligence said they had at least 1 machine gun nest, possibly anti-tank weapons, definitely dug-in infantry. Every previous assault had stalled at the first hedgerow. Tanks would climb, expose their bellies, and die. Today would be different, or today would be the end. The first hedgerow appeared through the morning mist, 12 feet of ancient earth and stone and roots. Behind it, Germans were waiting. Cullin gave the order. "Hit it at 15 degrees. Don't stop for anything." Mitchell gunned the engine. The rhinoceros lurched forward. 30 tons of steel accelerating toward a wall that had stood for centuries. The impact was violent. Cullin slammed forward against the cupola. Earth exploded around them. Roots snapped like bones breaking. For 2 seconds that felt like hours, the tank seemed to stall. Then it pushed through. They burst into the open on the other side. A German machine gun crew was scrambling for their weapon. They'd expected the tank to get stuck. They'd expected to have time. They were wrong. Harrison fired the main gun before they could react. 1 high-explosive round. The machine gun nest disappeared. "Keep moving," Cullin ordered. "Next hedgerow, same approach." The second hedgerow fell just as fast. Then the third. Each time the prongs bit into the earth, the tank stayed level, the belly stayed protected. Germans who had been confident behind their barriers suddenly found American armor in their faces with no warning. The strong point that had held for 3 days fell in 47 minutes. When the infantry caught up, they found German prisoners with their hands up and their eyes wide with shock. Captain Morrison arrived shortly after the battle ended. His face showed something Cullin had never seen before. Hope. "Sergeant, I just received word from Division. General Bradley wants to see your invention immediately. Major Williams has already filed a report recommending mass production." Cullin should have felt triumphant. Instead, he felt exhausted. "How many, sir?" "How many copies?" "They're talking about thousands. Every tank in Normandy." For a moment, Cullin allowed himself to believe it would be that simple. He was wrong. The next 72 hours would teach him that winning a battle was easy compared to winning a bureaucratic war. The meeting at 1st Army Headquarters happened on June 28th. Cullin stood in a tent surrounded by officers who outranked him by light years. General Omar Bradley was there. So was Major General Leonard Giroux, and Colonel Harold Pierce from Army Ordnance. Pierce was the problem. He was responsible for all equipment modifications in the European theater. Nothing got approved without his signature, and Pierce had already decided that Cullin's invention was unacceptable. "With respect, General," Pierce said, addressing Bradley, "this modification has not been properly tested. We have no stress analysis, no metallurgical evaluation, no engineering certification. Welding scrap metal to tanks in a combat zone violates 17 different ordnance regulations." Bradley's expression was unreadable. "Colonel, I've seen the combat reports. This device works. One engagement, sir. One. We don't know the long-term effects on tank structural integrity. We don't know if the welds will hold under sustained combat. We don't know if this modification creates unforeseen vulnerabilities." Cullin couldn't stay silent. "Sir, with respect, the current vulnerability is pretty well known. Tanks climb hedgerows, tanks get shot in the belly, crews burn to death. My modification stops that." Pierce turned to Cullin with barely concealed contempt. "Sergeant, you're a mechanic. You fix engines. You don't design military equipment. The Army has engineers for that. Trained professionals who understand the complexities you apparently don't. Those trained professionals haven't solved the hedgerow problem, sir. I have." The temperature in the tent dropped 10 degrees. Pierce's face reddened. "General Bradley, I cannot in good conscience approve this modification. If something goes wrong, if tanks start failing because of improper welding, if crews die because this device creates problems we haven't anticipated, the responsibility falls on whoever authorized it." Bradley was silent for a long moment. Then he spoke. "Colonel Pierce raises valid concerns. Sergeant Cullin, your invention is impressive, but we need proper evaluation before mass deployment. You'll have 48 hours to prepare for an official demonstration. If it passes, we proceed. If it doesn't, this discussion is over." Cullin's heart sank. 48 hours. Another test. More delays. Meanwhile, tanks were still burning. Men were still dying. But he had no choice. "Understood, sir." As the meeting ended, Pierce pulled Cullin aside. His voice was low and cold. "Listen carefully, Sergeant. I've been in this army for 23 years. I've seen dozens of field modifications come and go. Most of them killed more Americans than they saved. Your little invention might work in one battle. But when it fails, and it will fail, the blame won't fall on you. It'll fall on the officers who approved it. I won't let that happen. I'll be at your demonstration, and I'll be looking for every possible flaw." Pierce walked away. Cullin stood alone, wondering if he'd just won a battle only to lose the war. That night, Cullin found an unexpected ally. Major Jack Williams from Division Headquarters tracked him down in the motor pool where he was checking the rhinoceros for damage. "Sergeant Cullin, we need to talk." Williams was different from Pierce. Younger, less rigid. He'd been at the first hedgerow test. He'd seen what the invention could do. "I heard about the meeting with Pierce. He's going to try to kill this." "I figured that out, sir." "What you need to understand is why. Pierce isn't stupid. He isn't even wrong technically. Unauthorized modifications have caused problems before. Crews have died because of well-intentioned changes that weren't properly evaluated. He's protecting the system." "The system is getting men killed right now, sir." Williams nodded slowly. "I know. That's why I'm going to help you. The demonstration in 48 hours needs to be undeniable, not just successful. Spectacular. We need Pierce and everyone watching to see results so overwhelming that they have no choice but to approve." "What do you have in mind?" Williams pulled out a map. "There's a section of hedgerow country about 3 miles from here. Some of the thickest bocage in Normandy. 12 hedgerows in a half-mile stretch. Under current tactics, crossing that ground would take a week and cost us probably 8 to 10 tanks. I've arranged for the demonstration to happen there. You're not going to breach one hedgerow. You're going to breach all 12, in one continuous run, in front of every skeptic in First Army." Cullin stared at the map. 12 hedgerows. Some of them looked massive. "Sir, I've never tested against that many in sequence. The prongs might get clogged with debris. The welds might fatigue. There are a lot of unknowns." "Then you have 48 hours to solve them. I'll get you additional welder's materials, whatever you need. But understand something, Sergeant. This is your one chance. Pierce will make sure there isn't a second demonstration. Either you prove this works beyond any doubt, or it dies here." Cullin looked at the map for a long time. 12 hedgerows. One chance. Everything riding on 48 hours of preparation. "I'll need 6 welders, more scrap steel from the beaches, and I'll need to modify the prong design to prevent debris buildup." Williams smiled. "Already arranged. I told you, Sergeant. Some of us believe in what you're doing. Now prove us right." The next 48 hours were the most intense of Cullin's life. He barely slept. He redesigned the prong configuration, adding a debris-clearing mechanism inspired by agricultural equipment. He reinforced every weld on the rhinoceros. He trained the crew on the specific techniques needed for sequential breaching. He checked and rechecked every component until he could identify potential failures in his sleep. Other tank crews came to watch. Word had spread about what Cullin was attempting. Some offered help. Others came to mock. 12 hedgerows. He's going to get stuck on the third one. That scrap metal is going to fly off the first time he hits something solid. Pierce is right. This is some mechanic playing soldier. It's going to end badly. Cullin heard the whispers. He ignored them. He had work to do. On the morning of June 30th, he stood in front of the rhinoceros as the sun rose. The tank looked different now. The prongs had been modified, reinforced, optimized. This wasn't a prototype anymore. This was a weapon designed for exactly one purpose, proving every doubter wrong. June 30th, 1944, 0800 hours. The demonstration ground was a nightmare landscape of ancient hedgerows stretching into the distance. 12 barriers. Each one had been standing for hundreds of years. Each one had defied every attempt to breach it. A crowd had gathered. General Bradley, Major General Giroux, Colonel Pierce with his clipboard ready to document every failure. Dozens of other officers, engineers, observers. They lined the ridge overlooking the demonstration area. Some had binoculars. All had skepticism. Cullin climbed into the rhinoceros. His crew was already inside. Mitchell on the driver's seat, hands steady on the controls. Harrison manning the gun. Chen ready with ammunition they wouldn't need. Kowalski watching their flanks. "Gentlemen," Cullin said over the intercom, "we get one shot at this. 12 hedgerows. No stopping. No hesitation. We break through every single one, or we've wasted everything." "We're ready," Mitchell replied. "Let's show these brass hats what a mechanic can do." The signal came, a green flare arcing into the morning sky. The rhinoceros engine roared to life. Mitchell put it in gear, and they charged. The first hedgerow hit like a thunderclap. Earth exploded. Roots shattered. The tank shuddered but kept moving. They burst through into the field beyond. The second hedgerow was already ahead. No pause, no assessment, just forward momentum. Mitchell had the rhythm now. He adjusted their angle of approach, hit the second barrier at exactly 15 degrees. Another explosion of soil and vegetation. Through. Third hedgerow, massive. 15 feet of compacted earth and stone. Cullin felt the impact through his entire body. For a terrifying second, the tank slowed. The engine screamed. The tracks churned. Then something gave way, and they were through. On the ridge, the observers were silent. Pierce was scribbling notes furiously. Bradley watched with an expression no one could read. 4th hedgerow. 5th. 6th. Each breach was violent and loud and absolutely effective. The debris-clearing modification was working. The prongs weren't clogging. The welds were holding. Cullin allowed himself to hope. 7th hedgerow. 8th. They were more than halfway through. The rhinoceros was performing beyond anything Cullin had calculated. Mitchell was handling the tank like an extension of his own body. Impact after impact, breach after breach, the ancient barriers falling like they were made of paper. 9th hedgerow. Something was wrong. The tank hit the barrier and stopped. Not slowed. Stopped. The engine howled. The tracks spun. They weren't moving. Cullen's heart seized. This was it. This was the failure Pierce was waiting for. On the ridge, he could imagine the colonel smiling. "More power!" Cullin shouted. "Everything we've got!" Mitchell floored the accelerator. The engine screamed at a pitch Cullin had never heard before. Metal groaned. The entire tank shuddered like it was going to shake itself apart. And then, with a sound like the earth itself tearing open, the hedgerow gave way. They burst through so fast that Mitchell almost lost control. The rhinoceros fishtailed wildly before he corrected. 10th hedgerow. They hit it while still recovering from the 9th. Somehow it worked. Through. 11th. The prongs were getting dull. Cullin could feel the difference in how they bit into the earth. But they were still cutting. Still working. One more. One more hedgerow between success and failure. The 12th barrier loomed ahead. It was the biggest of all. 18 feet of ancient Norman bocage, a wall that had probably stood since before America existed. Mitchell didn't hesitate. Full speed. Maximum impact. The collision was catastrophic. Cullin was thrown forward so hard he saw stars. The sound was deafening. For what felt like forever, they were buried in the mass of earth and roots, unable to see, unable to move, unable to breathe. Then, daylight. They were through. 12 hedgerows, 12 breaches. One continuous run. Mitchell brought the rhinoceros to a stop on the far side of the demonstration area. For a moment, there was absolute silence. Then, the cheering started. It came from the infantry observers, first the men who had been walking behind hedgerows for weeks, watching their armored support die. Then it spread. Engineers, junior officers, even some of the senior brass. On the ridge, General Bradley was smiling. Beside him, Colonel Pierce had stopped writing. His clipboard hung at his side. His face showed something that might have been disbelief, or might have been defeat. Cullin climbed out of the rhinoceros on shaking legs. The prongs were bent and dull-caked with centuries of earth. But they had held. Every weld, every modification, everything he had built and calculated and hoped for had worked. Major Williams reached him first. "Sergeant Cullin, you just did something that every engineer in the Army said was impossible. 12 hedgerows in 17 minutes. The current tactical estimate for that same ground was 7 days with conventional approaches." General Bradley approached next. His handshake was firm. "Sergeant, I'm authorizing immediate mass production. I want 500 tanks modified by the end of the week. Colonel Pierce will coordinate the logistics." Pierce stood nearby, his face unreadable. "General, the demonstration was impressive, but we still need to evaluate long-term durability, standardize the manufacturing process, train crews on proper usage." "Then get started, Colonel. You have 48 hours to develop a production protocol. Sergeant Cullin will assist." Pierce looked at Cullin. Something had changed in his eyes. Not respect exactly, but acknowledgement. "Sergeant, it seems I underestimated you." "No, sir. You did your job. Someone has to ask the hard questions. I just had to provide better answers." For the first time, Pierce almost smiled. "Fair enough. Report to my tent at 1400. We have work to do." The next 2 weeks transformed Cullin's life. He went from anonymous mechanic to the most sought-after man in Normandy. Every tank battalion wanted the Hedgerow Cutter. Every commander wanted to know when they'd get their modifications. Cullin trained welding crews from dawn to dusk. He developed standardized specifications. He created training materials for tank crews. He traveled from depot to depot, inspecting installations, correcting mistakes, improving techniques. The production numbers were staggering. By July 5th, 200 tanks had been modified. By July 10, 500. By July 14th, over 1,000 rhinoceros tanks were operating across the Normandy front. The results were immediate and dramatic. Before the Hedgerow Cutter, American forces advanced an average of 800 yards per day through bocage country. After the cutter, that number jumped to over 3 miles per day. Tank losses to hedgerow ambushes dropped by 73%. The German defenders, who had relied on hedgerows as their primary defensive advantage, suddenly found themselves exposed. American armor could now appear anywhere at any time through barriers they had considered impenetrable. But not everyone embraced the change. Some tank commanders resisted. They developed their own techniques for dealing with hedgerows. They didn't trust this new equipment. They didn't want to change their tactics. Cullin found himself in arguments with sergeants and lieutenants who had more combat experience than him. "I've been fighting in this bocage for 3 weeks," one tank commander said. "Some mechanic isn't going to tell me how to do my job." "I'm not telling you how to fight," Cullin replied. "I'm giving you a tool that keeps your belly armor pointed at the ground instead of the enemy. What you do after you breach the hedgerow is your business." Slowly, grudgingly, the resistance faded. Combat results were hard to argue with. Crews who used the cutter survived. Crews who didn't took casualties. The math was simple. By mid-July, German intelligence had finally figured out what was happening. Captured documents showed their confusion. "Enemy armor is now penetrating hedgerow barriers through unknown means," one report read. "Defensive positions considered secure are being overrun within minutes. Request information on new American equipment." The Germans tried to adapt. They planted mines at the base of hedgerows. They positioned anti-tank guns at angles to catch breaching tanks. They created false hedgerows as traps. None of it worked consistently. The fundamental problem remained. The Cullin cutter allowed tanks to breach hedgerows while keeping frontal armor toward the enemy. As long as American crews used proper tactics, German countermeasures failed. On July 25, 1944, Operation Cobra launched, the long-awaited breakout from Normandy. Thousands of American troops surged forward, supported by armor equipped with Cullin hedgerow cutters. The bocage that had trapped them for 7 weeks was no longer an obstacle. It was just terrain. In 3 days, American forces advanced further than they had in the previous month combined. The German defensive line shattered. The race across France began. Cullin watched the breakout from an observation post surrounded by officers who had once doubted him. His invention was everywhere now. Standard equipment. Unremarkable. Just another part of how tanks worked. That's when he knew he had truly succeeded. When people stopped noticing. But success brought new complications. Cullin had become famous within the army. Generals wanted him at briefings. War correspondents requested interviews. Soldiers asked for autographs. He hated every moment of it. And then came the news that changed everything. Army intelligence intercepted a German communication. The enemy had captured a disabled rhinoceros tank. They were studying the hedgerow cutter, analyzing its design, looking for weaknesses, and they were sharing their findings with engineers in Berlin. The Germans were going to reverse engineer his invention. Or worse. They were going to develop countermeasures that would make the cutter useless. Everything Cullin had built, everything that was saving American lives, was suddenly at risk. In Part 3, we'll discover what the Germans learned from the captured rhinoceros. We'll see how their engineers attempted to neutralize the hedgerow cutter. And we'll watch Cullin face his greatest challenge yet. Because building an invention is one thing. Staying ahead of an enemy who wants to destroy it is something else entirely. The real war for the hedgerow cutter was just beginning. Previously on this story, a mechanic from New Jersey watched American tanks burn. He welded scrap metal to a Sherman and created a weapon that smashed through ancient hedgerows. The Army called him insane. Then they called him a genius. Within 2 weeks, over 1,000 rhinoceros tanks were tearing through Normandy. German defensive lines collapsed. The breakout began. American forces advanced further in 3 days than they had in the previous month. But then came the news that changed everything. The Germans captured a disabled rhinoceros. They were studying the hedgerow cutter, analyzing its design, developing countermeasures. And now, Army intelligence intercepted a message that made Cullin's blood run cold. Berlin had issued orders to every panzer division in France. New tactics, new weapons, new ways to kill the tanks that were killing them. The Hedgerow Cutter had worked too well, and now the enemy was fighting back. July 28, 1944. German High Command Western Front. Field Marshal Gunther von Kluge stared at the reports on his desk with growing disbelief. In the past 72 hours, his forces had lost more ground than in the previous 6 weeks combined. American armor was appearing in locations that should have been impossible to reach. Hedgerow barriers that had held for weeks were being breached in minutes. His defensive strategy was collapsing. "How is this happening?" von Kluge demanded. His intelligence officer, Colonel Werner Hoffmann, placed a captured document on the desk. Photographs of a Sherman tank with strange steel prongs welded to its front. "They call it the rhinoceros hair Feldmarschall. The Americans have developed a device that allows their tanks to cut through hedgerows instead of climbing over them. Our anti-tank teams are being overrun before they can engage." Von Kluge studied the photographs. The device looked crude, almost primitive. Steel beams welded to a tank. Nothing sophisticated. And yet this simple invention was destroying his entire defensive doctrine. "How many tanks have this modification?" "Intelligence estimates over 1,000, sir, and the number is growing daily." 1,000. Von Kluge felt the weight of that number. His forces had been relying on hedgerows as force multipliers. A single anti-tank team behind a hedgerow could destroy multiple Shermans as they exposed their bellies climbing over. That advantage was gone. Now his men were fighting American armor on equal terms, and in a battle of attrition, Germany would lose. "We need countermeasures, immediately." The German response came within days. New orders went out to every unit in Normandy. If hedgerows could no longer stop American tanks, then the ground behind the hedgerows had to become deadly. Engineers began planting teller mines at the base of hedgerows positioned exactly where the rhinoceros tanks would breach. Anti-tank guns were repositioned to fire at angles that would catch tanks emerging from breaches. Infantry units received new tactics. Instead of waiting behind hedgerows, they would fall back to secondary positions and ambush American armor from the flanks. The results were immediate. On July 30th, a rhinoceros tank from the 3rd Armored Division breached a hedgerow and detonated 3 teller mines simultaneously. The explosion killed the entire crew. The next day, 2 more rhinoceros tanks were destroyed by concealed anti-tank guns positioned to fire into breach points. Word spread quickly through American tank battalions. The Germans had adapted. The Hedgerow Cutter was no longer a guaranteed survival tool. It was still effective, but the enemy had learned. Cullin received the casualty reports with a sick feeling in his stomach. His invention was still saving lives. Tank losses were still 70% lower than before the Cutter, but men were dying in tanks he had modified, men who trusted his design, men whose faces he knew. But the German countermeasures weren't the only problem Cullin faced. August 2, 1944. 1st Army Maintenance Depot. A Sherman tank sat disabled in the repair yard. Its hedgerow cutter prongs had snapped off during a breach attempt. The welds had failed. The crew had survived, but the tank was out of action, and the mission had failed. It was the 4th such failure in 3 days. Colonel Pierce stood over the broken prongs, his expression grim. "I warned you about this, Sergeant. Mass production without proper quality control. Welders who weren't properly trained. Materials that weren't properly tested. Now we're seeing the consequences." Cullin examined the failed welds. Pierce was right. The breakpoints showed classic signs of metal fatigue and poor welding technique. In the rush to modify as many tanks as possible, quality had suffered. Some installations were being done by welders with minimal training. Some were using inferior scrap metal. The standardization he had tried to implement was being ignored in the push for speed. "How many failures total?" Cullin asked. 17 confirmed, probably more that weren't reported. "That's 17 tanks that went into combat trusting your device and found out it didn't work when they needed it most. The design is sound. The problem is installation quality." The problem, Sergeant, is that you created something that requires skilled installation and then let the Army mass produce it with whatever resources were available. This is exactly what I was afraid of. Pierce wasn't wrong. Cullin had been so focused on proving the concept that he hadn't thought enough about what would happen when thousands of copies were made under combat conditions. He had assumed everyone would follow his specifications. He had assumed quality would be maintained. He had been naive. The criticism spread beyond Pierce. Some commanders began questioning whether the Hedgerow Cutter was worth the trouble. Yes, it worked when properly installed, but improper installations were creating false confidence. Crews were charging into hedgerows believing their cutters would work only to get stuck or have their prongs snap off at critical moments. A few voices began suggesting that maybe the old methods were safer. At least with the old methods you knew what you were getting. The cutter was creating unpredictability. Cullin found himself defending his invention in meetings where he was clearly unwelcome. The solution isn't to abandon the cutter, he argued. The solution is better training and quality control. Give me 2 weeks. I'll personally inspect every installation. I'll retrain every welding crew. We can fix this. 2 weeks, one colonel replied. The war isn't going to wait 2 weeks, Sergeant. We need solutions now. For the first time since the Hedgerow Cutter's success, Cullin wondered if he had made a mistake, not in creating the device, but in how he had pushed for rapid deployment. Maybe Pierce had been right all along. Maybe proper testing and gradual rollout would have been better than the rush to get cutters on every tank as fast as possible. But then the reports came in from Operation Cobra, and everything changed. August 7, 1944. The town of Mortagne, France. German forces launched a massive counterattack. Hitler himself had ordered it. Operation Lüttich. 4 panzer divisions striking west toward Avranches, trying to cut off the American breakout and trap Patton's Third Army. It was Germany's last major offensive in France. 30,000 troops, 300 tanks. The fate of the entire Normandy campaign hung in the balance. If the Germans succeeded, they would split the Allied forces in 2. The breakout would fail. The war in Europe could be extended by months, maybe years. American commanders scrambled to respond. Units were rushed to defensive positions around Mortagne, and among those units was the 30th Infantry Division supported by Sherman tanks from the 743rd Tank Battalion. Tanks equipped with Cullin Hedgerow Cutters. The battle began before dawn. German panzers advanced through morning fog. American positions were hit with artillery and infantry assault simultaneously. The fighting was brutal, close quarters, chaotic, the kind of combat where seconds determined survival. Staff Sergeant Robert Thompson commanded a rhinoceros tank on the southern edge of Mortagne. His unit was tasked with holding a critical road junction. If the Germans broke through here, they would have a clear path to Avranches. Thompson's tank was positioned behind a hedgerow. Standard defensive doctrine. But the Germans were approaching from multiple directions. Staying in one position meant death. Thompson made a decision that would have been impossible 2 months earlier. He ordered his driver to breach the hedgerow and engage the enemy on the move. The Sherman surged forward. Steel prongs bit into ancient earth. Roots snapped. The tank burst through into open ground. A German Panzer IV was 50 yards ahead, turret turning to engage. Thompson's gunner fired first. The armor-piercing round struck the Panzer's side. The German tank shuddered and stopped. Smoke poured from its hatches. "Another hedgerow, 11 o'clock, Thompson's driver shouted. Thompson didn't hesitate. "Breach it!" The rhinoceros charged again. Another explosion of earth and vegetation. They emerged behind a German infantry position. Soldiers scrambled for cover. The tank's machine guns opened up. Then the main gun. Another Panzer appeared. Thompson's gunner was faster. Another kill. In the span of 15 minutes, Thompson's single tank had breached 4 hedgerows, destroyed 2 Panzers, and disrupted an entire German infantry company. This kind of mobile warfare would have been impossible before the Hedgerow Cutter. Tanks would have been trapped between hedgerows, forced to use roads predictable and vulnerable. Now they could go anywhere. Strike from any direction. Appear where the enemy least expected. Across the Mortain battlefield, similar scenes played out. Rhinoceros tanks breached hedgerows to flank German positions. They created new routes when roads were blocked. They turned the blockage that had once trapped them into a weapon against the attackers. The Germans had planned their assault assuming American armor would be channeled along predictable paths. They were wrong. By noon on August 7th, the German advance had stalled. By evening, it was collapsing. American forces, mobile and aggressive thanks to the Hedgerow Cutters, were hitting the attackers from directions they hadn't anticipated. German commanders reported confusion. Their maps showed hedgerows that should have blocked American movement. But American tanks kept appearing behind those hedgerows inside positions that should have been protected. August 8th. The German counterattack failed completely. Hitler's last gamble in France had been defeated. And military analysts would later point to one factor that made the difference: American armor mobility. The ability to breach hedgerows and strike from unexpected directions had turned a desperate defense into a decisive victory. The numbers told the story. During the Battle of Mortain, American tanks equipped with hedgerow cutters achieved a kill ratio of 3.2 to 1 against German armor. Units without cutters achieved only 0.8 to 1. Tanks with cutters suffered 64% fewer casualties than tanks without. In the 2 days of fighting, rhinoceros-equipped battalions breached over 400 hedgerows and destroyed or disabled 87 German vehicles. The 743rd Tank Battalion Thompson's unit was credited with destroying 23 enemy tanks while losing only 4 of their own. Before the Hedgerow Cutter, those numbers would have been reversed. The impact rippled outward immediately. Every tank commander in France wanted hedgerow cutters. Units that had resisted the modification now demanded it. The quality control problems that had plagued production suddenly became priorities. New training programs were implemented. Inspection standards were tightened. Cullin found himself overwhelmed with requests. Generals who had ignored him now sought his advice. Engineers who had dismissed his design now studied it carefully. The hedgerow cutter wasn't just a useful tool anymore. After Mortain, it was recognized as a war-winning weapon. General Bradley issued a statement calling it one of the most significant tactical innovations of the European campaign. Eisenhower's headquarters sent a commendation. The New York Times ran a story about the mechanic who changed the war. Cullin was promoted to Master Sergeant. He received the Legion of Merit. His name appeared in official Army communications as an example of American ingenuity. But more importantly to Cullin, the casualty reports showed the impact. In the month before the Hedgerow Cutter, American tank crews in Normandy suffered an average of 340 killed per week. In the month after widespread deployment, that number dropped to 89. 250 American lives saved every week. 1,000 per month. Because a mechanic from New Jersey refused to accept that a problem was unsolvable. The German response to Mortain's failure was telling. Within days, orders went out abandoning hedgerow-based defensive doctrine entirely. If the Americans could breach hedgerows at will, there was no point defending them. German forces began falling back to rivers and urban areas terrain where the hedgerow cutter provided less advantage. But they were too late. The Allied breakout was complete. Patton's Third Army raced across France. Paris was liberated on August 25th. By September, Allied forces had pushed the Germans back to their own border. Military historians would later calculate that the Hedgerow Cutter shortened the Normandy campaign by approximately 3 to 4 weeks. Those weeks translated to thousands of lives saved on both sides. Thousands of families who got their sons and fathers and husbands back. Thousands of futures that weren't cut short in French fields. The recognition continued. Cullin was flown to Washington to meet with Army brass. He was interviewed by war correspondents. His story was featured in newsreels, shown in theaters across America. The mad mechanic of Normandy became a symbol of the common soldier's contribution to victory. But Cullin found the attention uncomfortable. He'd never wanted fame. He'd just wanted to solve a problem. Every interview felt like a performance. Every handshake with a general felt hollow. The men who had actually used his invention, the tank crews who had charged through hedgerows trusting his design, they were the ones who deserved recognition, not him. He was just a mechanic who'd had one good idea at the right time. By October 1944, the Hedgerow Cutter had evolved beyond Cullin's original design. Tank crews in the field had modified it for different purposes. They used it to breach walls in urban combat. They used it for traction on muddy riverbanks. They used it to push aside roadblocks and debris. The simple steel prongs had become standard equipment modified and improved by hundreds of soldiers who saw problems and solved them just like Cullin had. The war moved on. The hedgerows of Normandy became distant memories as Allied forces pushed into Germany. The cutters remained welded to tanks used occasionally for unexpected purposes, a reminder of the summer when they had changed everything. But what happened to Curtis Cullin after the war? What became of the man who had transformed tank warfare with scrap metal and a welding torch? The answer to that question is surprising, because fame didn't follow Cullin home. Recognition didn't last. The man who saved thousands of lives would spend the rest of his days in obscurity, known only to military historians and the families of the men he saved. In Part 4, we'll discover what happened to Curtis Cullin after the guns fell silent. We'll learn why the most important tactical innovator of the Normandy campaign was forgotten by history, and we'll explore the final untold chapter of a story that proves one truth above all others. Heroes don't always get happy endings, but sometimes they get something better. Previously on this story, a mechanic from New Jersey watched his fellow soldiers burn inside Sherman tanks. Ancient hedgerows were turning Normandy into a graveyard. So Curtis Cullin did something insane. He welded scrap metal from German beach obstacles onto a broken tank and created a weapon that changed everything. The Army called him crazy. Then they called him a genius. Within weeks, over 1,000 rhinoceros tanks were tearing through barriers that had stopped the entire Allied invasion. At the Battle of Mortain, his invention helped defeat Hitler's last major counterattack in France. The breakout succeeded. Paris was liberated. The war in Europe was shortened by weeks, possibly months. Thousands of lives were saved. But here's the question nobody asks. What happened to Curtis Cullin after the guns fell silent? What became of the man who transformed tank warfare with nothing but determination and a welding torch? The answer to that question contains a twist that nobody expected, because success in war doesn't always translate to success in peace. And sometimes, the greatest heroes are the ones history forgets first. May 8, 1945, Victory in Europe Day. Across the Allied world, people celebrated in the streets. Soldiers wept with relief. Families reunited. The nightmare was finally over. Curtis Cullin stood in a small German town watching his fellow soldiers celebrate and felt nothing but emptiness. The Hedgerow Cutter had done its job. The war was won. But now what? 4 months, Cullin had been consumed by a singular purpose: solve the problem, save lives, improve the design, train the welders. Every waking moment had been dedicated to his invention and its deployment. Now that purpose was gone. The hedgerows of Normandy were a year in the past. The cutters were still welded to tanks, but nobody needed them anymore. The war that had given his life meaning was over. Cullin received his discharge papers in late 1945. He packed his medals, including the Legion of Merit, the Bronze Star, and the commendation from Eisenhower himself. He said goodbye to the men who had become his family. And he went home to New Jersey, to the same small town, to the same garage where he had fixed cars before the war. His wife Margaret was waiting. She had followed his story in the newspapers. She knew about the Hedgerow Cutter, the recognition, the fame. She expected a changed man. In some ways she got one, but not in the ways she had hoped. Cullin went back to work as a mechanic, not because he had to. The Army had offered him positions. Engineering firms had reached out. He could have leveraged his fame into a comfortable career. But Cullin didn't want any of it. He wanted to fix cars. He wanted to solve small problems with his hands. He wanted to forget. The war had left marks that didn't show on the outside. Cullin rarely talked about his experiences. When customers asked about his service, he would shrug and say he was just a mechanic. When friends brought up the hedgerow cutter, he would change the subject. When his children asked about his medals, he would show them briefly and then put them away. Margaret understood eventually. The man who came home wasn't broken. He was just tired. Tired of being special. Tired of being celebrated for something that was ultimately about killing. Tired of carrying the weight of all those lives saved and lost. He wanted to be ordinary again. And so he was. Years passed. The hedgerow cutter became a footnote in military history books. Cullin's name appeared occasionally in academic papers and specialized documentaries. But the general public forgot. There were so many heroes from the war. So many stories. One mechanic with a welding torch couldn't compete with D-Day itself, with the liberation of Paris, with the fall of Berlin. By the 1960s, Curtis Cullin was just another veteran. Another old man with stories he didn't tell. His neighbors had no idea that the quiet mechanic who fixed their cars had changed the course of World War II. And Cullin preferred it that way. But the legacy of what he built didn't disappear. It evolved. The hedgerow cutter's influence extended far beyond Normandy. Military engineers studied Cullin's design and recognized something profound. The principle wasn't just about cutting through hedgerows. It was about solving field problems with field solutions. It was about giving soldiers the ability to modify their equipment based on actual combat conditions. The U.S. Army created new programs to encourage what they called field expedient modifications. Soldiers were trained to identify problems and develop solutions just as Cullin had done. The culture of military innovation shifted. Instead of relying solely on engineers in laboratories thousands of miles from the battlefield, the Army began valuing input from the men actually using the equipment. The hedgerow cutter became a case study in military academies. Cadets at West Point studied how one enlisted man's observation had solved a problem that had stumped generals and engineers. The lesson was clear. Innovation could come from anywhere. The best solutions often came from the people closest to the problem. During the Korean War, American tanks faced new challenges in mountainous terrain. Engineers developed modifications inspired by the hedgerow cutter principle attachments that helped tanks navigate steep slopes and rocky ground. During the Vietnam War, similar field modifications emerged for dealing with jungle vegetation and rice paddy dikes. The spirit of Curtis Cullin lived on in every soldier who looked at a problem and thought, "I can fix this." The numbers tell the story of the hedgerow cutter's total impact. Military historians estimate that approximately 6,000 Sherman tanks were eventually equipped with some version of the Cullin device. These tanks participated in every major operation, from the Normandy breakout to the final push into Germany. Conservative estimates suggest the hedgerow cutter directly contributed to saving between 5,000 and 8,000 American lives. That's 5,000 to 8,000 families who got their sons back. 5,000 to 8,000 futures that weren't cut short in French fields. The indirect impact was even larger. By shortening the Normandy campaign by an estimated 3 to 4 weeks, the hedgerow cutter affected the entire timeline of the European War. Earlier liberation of France meant earlier crossing of the Rhine. Earlier push into Germany meant earlier end to the war. Every day the war ended sooner meant lives saved on all sides, American, British, French, and yes, even German. The ripple effects are incalculable. Modern military vehicles still carry echoes of Cullin's innovation. The mine plow attachments on M1 Abrams tanks use principles similar to the hedgerow cutter steel implements, designed to clear obstacles while keeping the vehicle's armor facing the threat. Combat engineering vehicles around the world feature modular attachment systems that allow field modifications, a direct descendant of the thinking that produced the rhinoceros. Even in civilian applications, the influence persists. Agricultural equipment manufacturers studied the hedgerow cutter when designing modern root cutting and land clearing attachments. The principle of using angled steel to cut through compacted earth remains relevant 80 years later. But the real legacy of Curtis Cullin isn't measured in equipment or modifications. It's measured in a lesson that applies far beyond military history. The hedgerow cutter story teaches us something fundamental about innovation. The best ideas don't always come from experts. Sometimes they come from people who are close enough to a problem to see it clearly, but not so invested in existing solutions that they can't imagine alternatives. Cullin had no engineering degree. He had no special training. What he had was direct experience with the problem and the mechanical intuition to recognize a solution. The experts had been trying to help tanks climb over hedgerows. Cullin asked a different question. Why climb at all? That shift in perspective from, how do we do this better, to, why are we doing this at all, is the essence of breakthrough innovation. The resistance Cullin faced is equally instructive. Colonel Pierce wasn't wrong to be cautious. Unauthorized modifications had caused problems before. The military bureaucracy existed for reasons, but that same bureaucracy almost killed an innovation that saved thousands of lives. The lesson isn't that bureaucracy is bad. The lesson is that systems designed to prevent failure can also prevent success. The challenge for any organization, military or civilian, is finding the balance between necessary caution and necessary risk. This pattern repeats throughout history. During World War I, a British officer named Ernest Swinton proposed using armored vehicles to break the trench warfare stalemate. Military leadership dismissed the idea as impractical. Winston Churchill, then First Lord of the Admiralty, championed the concept anyway. The result was the tank, a weapon that changed warfare forever. During World War II, Barnes-Wallis proposed bouncing bombs across water to destroy German dams. The idea seemed absurd. Wallis persisted. The result was Operation Chastise, one of the most famous raids of the war. In the Pacific Theater, an American submarine commander named Dudley Morton developed aggressive tactics that his superiors considered suicidal. His submarine, USS Wahoo, became the most successful American submarine of the war. Innovation in warfare almost always faces resistance. The innovators who succeed are the ones who find ways to prove their concepts despite institutional opposition. Cullin found Captain Morrison. Swinton found Churchill. Wallis found Air Marshal Harris. The pattern is consistent. Breakthrough ideas need champions willing to risk their careers on unproven concepts. And there's one final detail about Curtis Cullin that almost nobody knows. A detail that wasn't discovered until decades after his death. Curtis Cullin passed away in 1963 at the age of 51. Heart failure. He never wrote a memoir. He never gave extensive interviews. He took most of his stories to the grave. His family donated his papers to the National Archives, where they sat largely unexamined for decades. In 2004, a military historian named David Carter was researching tactical innovations of World War II when he discovered Cullin's personal notebook. The same notebook where Cullin had sketched his original hedgerow cutter design. But the notebook contained more than just those sketches. It contained dozens of other ideas, modifications and improvements that Cullin had never shared with anyone. There were designs for improved tank tracks that would perform better in mud. There were sketches for a rotating turret shield that would protect tank commanders from sniper fire. There were concepts for communication systems that would allow infantry to talk directly with tank crews. Some of these ideas were impractical. Some were ahead of their time, but several were remarkably sophisticated. Carter showed the notebook to modern military engineers. Their assessment was unanimous. Curtis Cullin wasn't just a mechanic who had one good idea. He was a natural engineering talent who could have revolutionized multiple aspects of armored warfare if given the resources and support. But Cullin never pursued those other ideas. After the hedgerow cutter, after the recognition and the medals and the pressure, he stopped sharing his innovations. The notebook was private, personal, a record of thoughts he never intended anyone to see. Why Carter found a clue in the final pages. A letter Cullin had written, but never sent, addressed to his wife Margaret. "The cutter saved lives," Cullin wrote. "I know that. I'm proud of that. But it also took lives. German boys who were just following orders just like our boys. Every time someone calls me a hero, I think about them. I think about what their mothers felt when they didn't come home. I had other ideas. Better ideas, maybe. But I couldn't make myself share them. I couldn't be responsible for more killing, even killing, that might save American lives. Maybe that's cowardice. Maybe that's wisdom. I don't know anymore. I just want to fix cars and forget." Cullin's notebook is now preserved in the National Archives. Historians consider it one of the most poignant documents of World War II. Not because of the technical innovations it contains, but because of what it reveals about the human cost of being an innovator in wartime. The man who saved thousands of lives spent his remaining years haunted by the lives his invention helped take. He could have been celebrated. He chose obscurity. He could have been rich. He chose his garage. He could have been remembered. He chose to forget. And that brings us to the end of this story. But before we go, let's remember what we've witnessed across these 4 parts. We watched a mechanic from New Jersey stand in a French field and refuse to accept that good men had to die. We watched him sketch impossible ideas in a notebook while his crewmates laughed. We watched him persuade a skeptical captain to give him 48 hours and some scrap metal. We watched his creation breach hedgerows that had stopped entire armies. We watched generals and colonels dismiss him, then demand more of his invention. We watched his rhinoceros tanks tear through German defenses at Mortain and turn the tide of Hitler's last offensive. And we watched him go home, put away his medals, and spend the rest of his life fixing cars in silence. From a mechanic with a crazy idea to a man who changed the course of World War II. Curtis Cullin proved something that remains true today. Innovation doesn't require credentials. It requires observation. It requires courage. It requires the willingness to be called insane by people who can't see what you see. By conservative estimates, the Cullin Hedgerow Cutter saved between 5,000 and 8,000 American lives. It shortened the Normandy campaign by weeks. It influenced military doctrine for generations. And it all started because one man looked at a problem everyone else had accepted and asked a different question. The next time someone tells you that your idea is crazy, remember Curtis Cullin. Remember that the experts were wrong. Remember that one sergeant with no engineering degree solved a problem that had stumped an entire army. And remember that the line between madness and genius often depends on nothing more than results. If you know a story like this one, a forgotten innovator, an impossible idea that changed history, share it in the comments. These stories deserve to be told. And if you want to discover more hidden chapters of military history, subscribe to this channel. Because the past is full of Curtis Cullins, ordinary people who did extraordinary things, and then went home and never talked about it. Curtis Cullin once wrote something in his notebook that captures everything this story is about. It was scribbled in the margin next to his original Hedgerow Cutter sketch. Just 6 words. But they might be the most important 6 words in this entire 90-minute journey. Someone had to try something different. That's it. That's the whole secret. Not genius, not credentials, not permission. Just the willingness to try something different when everyone else was doing the same thing that wasn't working. Someone had to try something different. Curtis Cullin did. And that made all the difference.